Welcome back to First Python Notebook. I'm again Ben Welsh, broadcasting live from Manhattan, USA. In this next chapter, we're going to go even further with the pandas data science tool. We're going to learn how to read in a data table or a spreadsheet of data from the outside world, not something we invented or made up, but something from real life. And the data set we're going to look at first comes from this story that you see in front of you on my screen. It's called Danger Spins from the Sky. The Robinson R-44, the world's best-selling civilian helicopter, has a long history of deadly crashes. And that headline ran on top of a story by myself and my colleague Kim Christensen that appeared in 2018. And it was based on a data analysis that I had done, as well as a whole lot of other reporting that Kim brought to the table about problems with the helicopter you see crashed in the picture before you, the Robinson R-44. Ultimately, we reported that it had the highest accident rate of any helicopter in the United States, any civilian helicopter, I should say. And that was based on a Python notebook that is linked from the materials in this class that you can read that I developed while reporting out the story. Ultimately, after a lot of work and a lot of learning, we focused in on two different data sets that we felt would help us establish the Robinson's safety record. One was a database of fatal helicopter accidents. Anytime a helicopter or an airplane crashes in the United States and someone dies, there's an investigation done by a federal agency known as the National Transportation Safety Board, or NTSB. The NTSB posts online the results of these investigations, and I found and downloaded thousands and thousands of records of all accidents for all aircraft over a long period of time from their website. And my Python notebooks, which I've published elsewhere, gather that data, refine it, clean it, standardize it, and ultimately output a list that looks something like this. This isn't necessarily the most legible thing to those who are unfamiliar with data, but anyone who's spent time working with spreadsheets knows what this is. These are comma-separated values, or CSV files. Each row is a record in a spreadsheet or database. The first row contains the headers or names of each column, and then the columns are then separated by commas. And so this right here is a data table or a spreadsheet that's ready to be parsed and analyzed by any data system, be it Microsoft Excel, Google Sheets, or pandas in Python. Now, this is a simplified list of all fatal helicopter accidents over a certain period of time that I dug out of a government database that had a few problems and a few things that needed to be smoothed over. For the purposes of this class, I'm leaving all of those problems to the side. This is much like a cooking show on television, a sort of simplified version of the process, right? Because we're focusing in this class on learning the fundamental skills. And if you're interested more in all the pieces that went into to prepare the data to get to this point, you can find my full notebook on GitHub. You could even download it and run it yourself and see everything that went into it. But for the purposes of simplifying things in the class, we're going to have our starting point be working with this spreadsheet, which has one row per fatal accident, right? And we can see there's a column there with the name of the helicopter. There's the Robinson R-44 again and again, right? We're going to read in this data set, and we're going to begin using pretty much strictly only the small set of skills we've learned thus far to start interviewing the data and conducting a data analysis. And that's what we'll do over the next few lessons. Now, the first skill or first trick we need to learn to begin this process is called read CSV. This is one of the pandas tools that I've told you about on the tool belt, and it can take a CSV like this and read it in as a pandas object that it's ready to work with. So we're going to go back to our notebook and we're going to do that. Before I go, I'm going to copy the URL to this CSV file. The URL for the CSV is available in the documentation for this chapter. I would suggest that you copy and paste it too. It's a little long, and I'd hate anyone to try to type it by hand. Now I'm going to go back to our notebook where we left off in the last chapter. Again, we have all the stuff we learned in our introduction to pandas sitting there in a notebook. I'm ready to get rid of it and just kind of begin again. And so I'm going to start just below where we import pandas because I want to keep that cell I'm going to click on the cell just below it, and I'm going to repeatedly hit the scissor key till I've deleted all of our materials from before. And now I'm back down to where I want to be with my headline, my byline, of course, we can't lose that, and the import of pandas, which makes it available to us in subsequent cells. If you've stopped and started your Jupyter Lab since the last time we did in class, you're going to want to replay that pandas line to get pandas imported. Every time you turn off your notebook or restart your computer and restart it, the code cells have to be rerun. You can't just assume that all the variables are in place every time you open it. So now I have pandas installed and available at PD. So I can then do PD dot, and again, if I hit tab, we get all of our many tool belt tools. And we can see if I scroll down to the R's, there's all these different methods for the different file types that Panda knows how to read in, right? And the one that I want, because my data is comma separated values, is CSV. So then if I get that function, I do an open parenthesis. Now our URL is a string of characters. So just as we learned earlier in class, a string of characters in Python needs to go inside quotes. So I'm going to do open quote, paste that URL, which is real long, close quote, and then close the parenthesis. And so that's going to pass that long URL of data into the read CSV function and ask pandas to read it as a table. I hit play, and boom, it happens real quick. You can see printed out here below, in the cell below is kind of a fancy little spreadsheet printout with alternating colors and a hover effect, headers at the top, very much like you might see in a spreadsheet in Microsoft Excel or elsewhere. And so we now have a sort of pandas version of a spreadsheet, which is a collection of columns, right? Each row being an individual record. And in the language of pandas and other computer programming tools, this is not called a spreadsheet. It's called a data table. But that's just a different word for the same thing, right? Data table is just the jargon for we now have a collection of columns or a table that we can work with. But if we want to do anything with it, of course, we have to save it into a variable so it can be used in subsequent cells. So once it runs, you go back to the left-hand side and we're going to type in there a variable. I'm going to call it accident underscore list. And so if I do accident underscore list equals, and then that same line of code, we now see that nothing is printed out below. And that, of course, is because our data frame has been saved into the accident list variable, which we can reuse in the subsequent cells. The first trick we're going to learn on a data frame is one that allows you to take a peek at what's inside of it. So you've read in a big table of data, you want to have a look. You want to see what's in there. If you do a dot after the name of your variable and then head, open parenthesis, close parenthesis, that will print below the first 5 rows of your data. Just by default, 5 is the number they chose as a starting point. So that's what we see here. And we see that in our first 5 rows, there's a Bell, a Robinson, 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 Robinson. We can even see here in the model field, there's a little bit of variation. This is an R22 beta, R44, R44-2. You can see the locations of the accidents and the dates. And, you can begin to kind of make sense of what's there. A couple important fields that we're going to use later on as part of our analysis when we're interviewing the data. You can see we have the location, the city and state of the accident. We have the total number of fatalities, because remember, a fatal accident can kill, more than one person potentially, one being the minimum number. We see here this accident had 3 deaths. And then crucially on the right-hand side, we see that there are these columns that begin with the term LA times underscore. So what these are the result of the work that I did as part of my research as a reporter. So the raw data that came in from the government had these small variations in the names of the makes and models. It was just a bit of dirtiness in the government data where things weren't standardized and consistently entered across the years. And so what I did after a period of research, consulting experts, doing a lot of reading about how helicopters have been made through the years, I decided that it was safe for us to make a sort of substitute columns that had common make and model names in cases where the raw data had a little bit of variation. And this is a really common data cleaning technique that journalists use to create columns that are safer to analyze without having a lot of noise or strange variations, but also without losing your connection to the original raw data, so that if you want to audit your work or go back and look at it later on, you maintain in the data set both the raw value that came in from the source unedited and the refined or clean value that the journalist has put in there. And so in a real life story, these columns, of course, would not be there for you. You might have to add them yourself. But to make things simpler in the course of this class, I've included what was my finished version of those. And this process of just kind of getting to know your data, going on a first date with it, trying to understand what is in each of the rows, trying to look for red flags of anything that might be a little strange or off, as we see with those variations, kind of thinking through what the different columns make possible in terms of analysis is just a great way to get going as a journalist with really any data set. And if you become a professional data journalist, you'll have this getting to know you first date with dozens or hundreds of data sets a year. It's a really common practice. And so head is a really useful tool just to look at the first few rows. And, it doesn't have to necessarily be the first 5. The head function takes an input like most other Python functions. If I put the number 1 in there, it will just return 1. If I put the number 10 in there, it will return 10. And that's an example of sort of overriding the default behavior by providing your own input, where, of course, the default was 5 rows. Another really helpful first date function for any pandas data set is the info function. So if you do the name of your data frame dot info, open parenthesis, close parenthesis, it will put out a little report card about the data set as a whole. So rather than just giving you a peek at a subset or a slice of the data, which is useful, this gives you a higher level view, a kind of background report on the whole data set. And it gives you a list of all the columns, right? So you get those a nice list. It tells you what data type they might be. So these are integers or numbers. When something is an object, that means Python thinks it's characters or strings. And you can kind of see those data types. We can see we have a date column, but it hasn't been parsed as a date. So that might make some operations interesting later on. Have to keep that in mind. And also a really important thing here is it gives you tells you how many records there are. So we're looking at a universe of 163 fatal accidents. And it lets you know for each column whether or how many values there are. And so there are, of course, cases in data sets where there are missing values or empty cells in the spreadsheet. In the language of Python, those are known as null values or empties. And so we can see here that there's 163 total rows, and almost all of our columns are fully filled in, though there does appear to be one record that doesn't have a state, where the state is empty. It might be interesting to look for that later. And so those two tricks, again, head and tail, are really or head and info are really great basic getting to know you functions to run after hitting read CSV. I just accidentally mentioned a third one, which I'll show you now. If I type in accident list, there's one called tail, which is the opposite of head, where head is giving you the first 5 rows in the data set. Tail is giving you the last 5 rows, right? And we can see here, these are from 2016, whereas these are from 2006, right? Suggests perhaps the data set's in chronological order, though it doesn't necessarily prove it. And so head, info, and tail are a great way of checking out your data frame after you've pulled it in via read CSV. In the next chapter, we're going to move on to accessing these individual columns, which are data series, just like the ones we learned earlier, and beginning to analyze those. I'll see you then.